Okay, YouTube, in this video we're going to explore how rectangular coordinate pairs are related to polar coordinate pairs. And that is to say that if we have some point, say xy, in the xy coordinate plane, could we relate the values of x and y here to the values of r and theta that tell us the same location but tell us in a different fashion? And so what I want everybody to see here is this. Starting with the fact that we have some point r theta, we could graph this point here, r theta, by proceeding in the theta direction are units from the pole or from the origin. And so what we see here is that representing this in an xy fashion, if xy is the same point, we could also see that we are directly to the right of the origin x units and directly north of the origin y units. And so what you could see is how these two things are related here. So what I want to do is I want to sketch this off on the side. And what we're going to say essentially is that we know the distance from the pole here at the origin to the point. This is this distance r. Of course we have a right triangle here, but we also know this angle theta, and what we want to do is relate it to x and y. And so certainly we've seen this situation before. We're just going to talk about some SOHCAHTOA mathematics. And that way, when we receive a point in r theta form, we're able to rewrite it into xy form. In other words, go from polar to rectangular form. And likewise, we know how x and y are related to r and theta, then we could rewrite things from xy form into polar form. So let's go ahead and set up our relationship between our angle and our hypotenuse here, length, with our side of our leg, or the length of our legs here, x and y. And so SOHCAHTOA mathematics, let's go ahead and write down a few things that we know here, starting with sine. If we were to find the sine of our angle theta, our sine of our angle theta here would be equal to our y over our r value. And certainly this is the definition of sine in the xy coordinate plane. So likewise, we could find the value of cosine of theta by expressing it as x over r. And then also we could say that the tangent of theta really is our opposite over adjacent, y over x. And so a few things we want to point out here are how x and y are related to r and theta. So when you look at these top two formulas here and here, what we're going to do is we're going to start by relating y to theta and r by getting y by itself. And the way we're going to do this here is we're going to multiply both sides by r. And so what we certainly get is this sine of theta is y over r. We're going to multiply both sides of this expression by r. And what we end up with is this expression that says, look, if you know r and theta, you can tell me the y value of your point, because all we have to do is take that r value times the sine of our angle. Likewise, if we want to know, well, how could we solve for x in terms of r and theta? We could say, well, taking our equation here, cosine of theta equals x over r, and multiplying both sides by r, that way our r and our theta are on the same side, and we've isolated x, then we get x is equal to r cosine of theta. And so this is uber important here, very imperative, that we know that y in terms of r and theta are r sine theta. Y is r sine theta, and that x in terms of r and theta is r cosine theta. So we say x is very cosine and y is very sine. Now likewise, when you look down here, what you see is this. This is going to relate x and y to our angle theta. Okay, so we could always relate x and y to our angle theta by using this last notation down here. Tangent of theta is equal to y over x. What I'm going to do is I'm going to focus on these two for right now, and let's go ahead and generalize a couple of the things we see here. Now, one thing that I realize that I've forgotten to mention here also that is very true about our relationship between x, y, and r and theta is this. Recall that x squared plus y squared in this case would be equal to our r squared. And so what this allows us to do is relate our x and our y values to our r value here. So that is to say, if we knew r, we could write it in terms of x and y, and if we knew x and y, we could plug those in and find our r value. So one thing that we are interested in doing a lot of the time is actually searching for r. So what you're going to see here is that if I were to take this equation and take the square root of both sides, what we could see then is that r is equal to the square root of our x value plus our x value squared plus our y value squared, or the square root of the sum of the squares here. And if we were to solve this equation here for theta, we have this equation tangent of theta equals y over x. What we would do is we would take the tangent inverse, okay, of both sides of this equation to isolate our theta here. But what we could see is that theta, I better keep up with the scheme here, theta in terms of y and x is always the tangent inverse of y over x, or at least what I want to say here is that this is the reference angle. And so here's the neat thing about it. if we want to know x and y, and we already know r and theta, then these are these formulas here that we could use in order to obtain that information. And if we know x and y already, then we could plug these into these purple formulas here to obtain our r and our theta. And so that is going to be of primary interest to us to be able to convert back and forth here. But you'll see that I provided a little information table down here to kind of generalize this statement. So here's what we want to basically mention. 1, always draw a picture, okay? And then 2, SOHCAHTOA math works. So if you cannot remember these formulas, which shame on you if you cannot remember these, we're going to use them a lot basically, and so you will know them. But if you cannot remember these two formulas here, we can still, if we knew x and y, draw a picture and work backwards to find out the value of r using Pythagoras and the value of theta using inverse trig functions here. So in our next video, what we're going to do, or next videos what we're going to do, is we're going to work on, if given something in rectangular form, converting it into polar form, and then vice versa. If given something in polar form, converting it back into rectangular form.